So in the last case, when we found the confidence interval for population mean, the point estimate was X bar. Here it is P hat.
P hat.
Just like last time we had mu hat or X bar. Here it is P hat. That's one change.
You like the little.
The other change is we use P instead of mu. So P last time it was mu. The relationship between C and alpha, it does not change. So if the confidence level is given, I can find the significance level and vice versa. Last time, in the previous section, we had to multiply the critical value with the standard error to get the margin of error. Yes.
Yes, we're fine.
Now, I had two things. What are the two things, or what were the two things?
The critical
Critical
value.
value
And yeah.
I just call it SE because it's a lengthy formula. I'm going to write it on the side. So what distribution did we use to find the critical value last time?
Inverse T.
Inverse T. So if you look at the notation, I use T sub 1 minus alpha over 2, comma, n minus 1. Here, it's simply Z sub 1 minus alpha over 2. That said, what function would you use in the calculator to find the critical value? A bit louder.
Inverse norm.
Inverse norm, very good. Z stands for a standard normal distribution. In other words, we are simply finding a Z-score, just like we did and found the T-score using a T distribution. So no need for n minus 1 because we never used the sample size when we did inverse norm. What is the mean of a standard normal distribution?
0.
And what is the standard deviation?
1.
1. So the mean is 0, the standard deviation is 1. So we can easily find this value using the calculator. We did a whole bunch of problems in section 5.3. Now on to the standard error. The standard error is not the same as the last formula. Here it is
Okay.
P hat multiplied by 1 minus P hat divided by n. Going back to binomial distribution.
Yes.
If the success probability was P, I call the failure probability using a different letter. What is that letter?
Q.
Q. Q. So P hat multiplied by Q hat divided by n. So I believe that your book uses this particular expression, P hat and Q hat. Straight and all, going back to P hat. How many of you dressed up for Halloween? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay.
30 something.
34. So, how about 34 students here? And out of the 34, 11 of you told me that you wore costumes for Halloween. So that is the number that favors whatever event that you have. So that is X.
We're 35.
Really? And divided by N. So B hat is simply X divided by N, where N is the total sample size. And X would be the number of outcomes that would favor a specific event in the proportion. In my example, 11 was the number of people who wore costumes for Halloween. 34 was the total, or is the total. So we know how to find the critical value. We know how to find the standard error. We put it in the formula, multiply, we get the margin of error. And the last step is to find the interval for P. Last time, when we found the interval for mu, we added and subtracted the margin of error from the sample mean. Here, we are going to add and subtract the margin of error to and from the point test.
And that's
Big
not going to find what?
What
What is that equation finding?
confidence interval?
The standard error, the equation at cap there, is that just two different ones or?
It's the same thing.
1 minus Q.
1 minus P hat is Q hat.
Okay.
Right, just like binomial. P, 1 minus P is Q. So everything follows the same procedure as the previous one. The things that differ are simply the formula for standard error and where you get the critical value from, and the notation, of course. One of the most common mistakes here when you evaluate this in the calculator is failing to put parentheses. And if you did that, you're going to get the wrong answer. So all of that must go inside the radical. Good? Parentheses, your friend.